Welcome back. We'll continue with the discussion on DFT. All right. Now we know the DFT expression is summation k running from n equal to 0 to n minus 1 x of n e to the power of minus j 2 pi by n k n. Right? We also wrote it like this. We also said this is n equal to 0 to n minus 1 x of n w n raised power k. We also write it like this, right? So let's write it like this, where Wn is e to the power of minus j 2 pi by e, right? So this is referred as the two-idle factor. Now first we'll see an important property of DFT, that's called the periodicity property. Now we say if we replace k by k plus n in this summation, what will happen? So what we'll have is that summation k running from n equal to n. Let me use this expression instead of this. So minus j 2 pi by n k is replaced by k plus n. So what will happen here? This will be the summation n running from 0 to n minus 1 x of n. Now separating the two terms, this will be kn, and then this will be n times n, right? So this is summation kn from n to the 0 to n minus 1 x of n e to the power of minus j 2 pi by n k n e to the power of n, and n will cancel here. This will be minus j 2 pi n. Now what's this term? Now look at this term. This is simply x of k. X, so we call it the DFT. This is the DFT expression. But what is this? Integral multiple of cos 2 pi plus j sine 2 pi. It's always equal to 1. So what we got? We got x of k plus n is equal to x of k. And this is referred as periodicity property of DFT. So this is referred as the periodicity property or the periodic property of DFT. And this is true, remember, this is true for all k as well as n. If it was n here, so because it is k here, let me write on it. So this is true for all k, right? All right. Now the next thing that we learn, if we replace k by k plus n by 2, what will happen? So from the definition, so putting this in definition, so n e to the power of minus j 2 pi by n, and k is k plus n by 2 n. And this will be summation k running from n to n, separating the two terms again. This will be minus j 2 pi by n k n e to the power of minus j 2 pi by n by 2 n. Right? Again, have a look at this expression. What is this? This is simply DFT of x of n. And what is this expression? So 1 and n will cancel, 2 and 2 will cancel. This will be simply e to the power of j pi. And since n is an integer, so this will always be minus 1. So this term will be minus 1. So this is x of k, and this will be minus 1. All right. So this is referred as antisymmetric property, right? So x of k plus n by 2. I will write the same properties in terms of two-idle factor. Two-idle factor. If we say Wn, so please remember these two properties. These are very, very important. Please remember this. Often used for the calculations of FFT and IFFT. FFT means fast Fourier transform. IFFT means most fast Fourier transform. So this is fast Fourier transform and inverse fast Fourier transform. So these are the two. This is used for these two expressions. One is this the x of k plus n by 2 and x of k plus n. This property are often used to evaluate this. And remember, fast Fourier transform is an algorithm. It's not a transform. It's an algorithm. So it's not a transform, but an algorithm. So if we get time, we'll do this. It's an algorithm to evaluate this. Means how do we compute this fast? That's why it's referred as fast Fourier transform. Now how do we compute this very fast? That's an algorithm, not a transform. So FFT is an algorithm to evaluate x of k actually. Now let me show you the same properties in terms of m. This Wn, sorry, these are two artifacts. The two artifacts is j to power by n, right? Now if I say Wn is equal k plus n, what is this? This should give me Wk if it follows periodicity property. So what we will write it? So we will minus Wn k plus n, substituting this will be j to power by n k plus n, and if I evaluate this, j to power by n minus k will be e to the power of minus j to power by n, and you'll see this is e to the power of, let me not substitute, this is simply w raised to n. K, but what is this? N and n will cancel. This is 1. Again, with no 1. So we prove that w n raised power k plus n is equal to w n raised power k. So this is the periodicity property in terms of Poisson factor. So this is the periodicity property in terms of Poisson factor. Now, if we now the next that will prove is w n k plus n by 2. Now what is this? Substituting this 2 pi by n k plus n by 2. This is same as e to the power of j 2 pi by n raised power k e to the power of minus j 2 pi by n by 2. Now see this n and this n will cancel, this 2 and 2 will cancel. So we are left with e to the power, what is this? This is Wn raised power k. This is Wn raised power k. What is this? E to the power of minus j pi. Right? What is e to the power of minus j pi? It's minus 1. So this will be Wn raised power k. Right? Minus 1. So what we have shown, one more result that we have shown here is Wn plus k plus n. By the way, it is true in terms of n also. I mean small n I'm talking about. So this is Wn raised power k. This is again the second property in terms of Poisson. Please remember these two properties. Alright, this is true for all k and also m. Instead of k, if I write m there, this is also true for that, and this is also true for k as well as. Alright, you can prove it. Alright, let me end this session here. In the next session, we'll see the circular shift of DFT. Alright, let me end this session here.